Hello everybody, in this video we're going to talk about area of a sector and what that is and how we can calculate it. So what is a sector of a circle? It is simply just a region that is bounded by two radii of the circle and their intercepted arc. So here in this diagram that we see right here, we have a radius of AB and a radius of AC. So there's our two radii. Our intercepted arc here would be arc BC. And so now basically this entire shaded red region is our sector of the circle. So we're going to find the area of this sector. And what area is, area of the sector, it is just the ratio of the area of the sector to the area of the circle is equal to the ratio of the measure of the intercepted arc to 360 degrees. So if you had trouble following that, look at our two equations we have here in yellow. So this first one that we see right here, this is basically us taking what we just read in red there and writing it as an equation. So the ratio of the area of the sector to the area of the circle. So that's what we see on the left side, right? Area of a circle is pi r squared. That's why we see pi r squared right there. Is equal to the ratio of the measure of the intercepted arc. So there's our measure of intercepted arc to 360 degrees. So there's our 360. So now if we want to simplify this so that we can say, hey, area of the sector is equal to this, then all we have to do is multiply both sides by pi r squared here, and that gives us this equation right here. So this is our simplified equation that tells us what the area of the sector is actually equal to. So we're going to say the area of the sector is equal to the measure of the intercepted arc divided by 360 times pi r squared. Okay, and we're going to look at about 3 or 4 examples on how to use this and finding different things, whether it's finding the area of the sector, the radius of the circle, the area of the circle, or the measure of the intercepted arc. So the first one here just says find the area of the sectors. So notice we have a sector here and we have a sector here. So we will call these two sectors by their size. So this one we'll call the small sector and this one we'll call the large sector. So the small one, so we'll just say small is equal to the measure of our intercepted arc. So that's going to be 135 degrees divided by 360 times pi r squared. Well, r here is 15, so 15 squared. Okay, so now we can say this is equal to 135 over 360 times 225 pi, because 15 squared is 225. So now in your calculator, you can do all this. So I'm going to do 135 divided by 360, and I'm going to hit enter. And that gives me 0.375. And now I'm going to multiply that by 225 pi. And my answer here for the small sector, it has an area of 265.07. And we're working with square centimeters. So that's the area of our small sector. Okay, now for the large sector, we will say large is equal to, and now we got to think about if our entire circle has a measure of 360 degrees, this small intercepted arc had a measure of 135, then we are left with a measure of 225 degrees, right, for our large sector. So 360 minus 135. So that's over 360. And then the rest of this is still the same. So this is 225 pi. So we can do 225 divided by 360. That gives me 0.625. And I'm going to multiply that by 225 pi. And for our large sector, we are getting 441.79 square centimeters. All right, let's look at example 2. Example 2 says find the area of the circle. So now we are given the area of our sector right here. So we can say 35 is equal to, and now we need the measure of our intercepted arc, which is 40 degrees over 360 times pi r squared. So now remember, area is equal to pi r squared. So we could go ahead and say that 35 equals 40 over 360 times the area, and we can just solve for a. So now I'm going to multiply both sides by 360 over 40, and that will cancel out over here. So 360 times 35 and divide that by 40, and we get an area of 315, and we're working with meters. So our area of the entire circle would be 315 square meters. All right, example 3. Now we want to find the measure of the intercepted arc, okay? So we know we have the area of the sector, it is right here. So we could say 214.37 is equal to, now our intercepted arc would go on the top of our fraction, so we're just going to say x for right now. We know that's divided by 360, and we're going to multiply by pi r squared. So now we have 214.37 equals x over 360 times, and 17 squared is 289, so we can say 289 pi. Now if we want to on the right side, we could go ahead and multiply these fractions. So this would be 289 pi times x over 360. We just multiplied straight across there. So now I'm going to multiply both sides by 360. So we're kind of just doing this one step at a time. That's going to cancel the 360. So 360 times 214.37, and that gives me 77,173.2, and this is equal to 289 pi x, right? So now we want to solve for x, so we're just going to divide by 289 pi, divide by 289 pi. That's going to cancel 289, and it's going to cancel pi. So divide by, and I'm going to put this in parentheses now, 289 pi, close the parentheses and hit enter. And this is going to give me x is equal to, and my calculator says 84.99999, so we'll say this is 85 degrees. Okay, so that is the measure of our intercepted arc. We're going to say it is 85 degrees. Okay. All right, last example, we're going to find the area of the shaded region here. So if we notice, we have a square, a 20 by 20 square. So let's say that the area of the square is 20 times 20, which is 400 square inches, right? And now we have 4 circles in here. They are all congruent circles. So we just need to find the area of one of these circles, multiply it by 4, and then we can subtract those areas from 400 to get the area of the shaded portion of this square. So we know that our circles are pi r squared, and we just got to figure out what r is. Well, if our entire distance here is 20, that means from here to there is 20, so that means halfway right there, that would be 10, right? Which means our radius here would be 5 inches, okay? So now for our circle, we're going to say the circle's area is equal to pi times 5 squared, which is equal to 25 pi. This is for one circle. So we're going to multiply this by 4 since we have 4 circles, and that gives us 100 pi for our 4 circles. So now we're going to take 400 and 100 pi, and we're going to subtract them. And that's going to give us the area of our shaded region. So 400 minus 100 pi, okay? And that's going to give me 85.84. So we'll say that the area of our shaded region, so area of shaded region equals 85.84, and that is square inches. Okay, and so that is how you can find the area of a sector, and also how you can use area of a sector to find the area of the circle, how you can find the radius of the circle, how you can find the measure of the intercepted arc, all of those different things.